Hello, welcome to our video for lesson 2.2 on mathematical expectation. So first of all, what is mathematical expectation and why do we care about it? I'm going to motivate this with an example. My daughter made a game for her school fair and is going to donate the profits to the local food shelf. She made a spinner with 6 equal parts, numbered 1 through 6. And don't mind my drawing, pretend those look equal. The rules are A, if you land on an odd number, you win a candy bar. B, if you land on a prime number, you win a pack of gum. And C, otherwise, you lose. The candy bars that she gives out as prizes cost her 20 cents each, and the packs of gum cost her 75 cents each. If she charges each person 75 cents per spin, what can she expect as an average profit from each spin? We're going to find out using mathematical expectation. Let's look at the formal definition of mathematical expectation. Suppose that we have a discrete random variable, capital X, with a probability mass function, little f of x. If u of x is some function of the random variable x, then the mathematical expectation, also called the expected value, of u of x is given by this formula. Essentially what we're doing is for every value of x, we're going to evaluate the function u of x, multiply it by the probability that x takes on that value, and then we're going to add those up for all the different values of x. Let's go back to our example. Okay, so if our random variable x is the number on the spinner, and we want to know what the PMF is of x. Since we have equally likely outcomes, this is our old friend, the discrete uniform distribution. And f of x is going to be 1/6 for each possible outcome. There's our PMF. Okay, now let's think about our function. Let's call u of x the profit. We're going to evaluate this for each of the possible values of x. So if the person spins a 1, the profit is going to be the 75 cents they paid minus 20 cents because this person wins a candy bar. 1 is an odd number. 1 is not considered a prime number, so they don't get a pack of gum, and so their profit that my daughter would get would be 55 cents if someone spun a 1. What if someone spun a 2? If someone spun a 2, that's not an odd number, so they don't get a candy bar. But it is prime, so they win a pack of gum, and so they would get a 75-cent pack of gum. They paid in 75 cents, and so the profit would be 0. If somebody spun and landed on a 3, they would have paid in 75 cents. My daughter would have to pay out 20 cents for the candy bar because that is an odd number. And she'd also have to pay out 75 cents for the pack of gum because it's also prime. So she would actually lose 20 cents on that spin. Similarly, we can find u for 4, 5, and 6. And that is our u of x. Okay, let's go back to our formal definition now. We have our formula, and we're going to see how we can take a look at it. So we want to figure out the expected profit for each spin. That's our expected value of our profit u of x. What we're going to do is we're going to start with our first value of x, so x is equal to 1. We're going to take u of 1 times f of 1. Then we're going to add to that, going to 2, u of 2 times f of 2. And then we need to add u of 3 times f of 3, and continue all the way up to u of 6 times f of 6. If we go back and we plug in the values that we have up above, and do a little arithmetic, we get an expected value of 27.5, which means that the expected profit would be 27.5 cents per spin. Thanks for watching.